There we go. Okay. Hopefully you guys can hear me on the Zoom okay as well. All right. Cool. Sweet. So welcome back. Lecture 5. We're going to be building some tables today. Before we do that, sorry, I'm on Zoom on this too, but it's like, there we go. Yes. Okay. All right. So a few announcements to start. So lab 2 is due today at 11 p.m. if you're in MegaLab. Homework 2 is out due Wednesday. Congrats on finishing your first homework assignment, by the way. And you can submit it on Tuesday a little bit early for extra credit as usual. And office hours have begun, so please come to those. I didn't have mine this week, but mine are starting this Sunday. And so just to recap for mine, there's Sunday 4 to 5 p.m. on Zoom, and then Mondays 11 to 12 at Cafe Strada. So I'll start those on Sunday. So please come out to my office hours and come out to everybody's office hours. We have a lot of staff here available to help you with your assignments, help you with the Python, debug any issues with your code. So please come out for that. And then we also have tutoring signups live on EdNow. So this is a resource that we mentioned kind of in the first lecture. So in addition to all the amazing GSIs that we also have an entire staff of tutors to provide support. And so, if you feel like you're, stuck on anything, just get a head start, start requesting that support now. And, it's going to be there throughout the semester, but sign up now if you want to just get a head start there. Cool. So in terms of what we're doing this week, wrapping up the week really, we started out with Python basics, went over a little bit about tables, different things that we can do with tables. On Wednesday, we talked about different types of data. We went over like integers and strings and floats and all that stuff. And then also went into arrays. So we'll kind of wrap up arrays today, talk about how we can make new tables from scratch. And then also talk about how we can manipulate tables and especially the columns of the tables. That's typically what we're going to be doing throughout a lot of this course. It'll turn out that like columns are very interesting in tables, and columns actually are arrays, it turns out. And so that means that there's all kinds of interesting math that we can do on those columns of the tables that we're going to be working with. So we'll go into that a little bit today as well. Cool. So one thing I wanted to recap really quickly, this is just kind of fun, but you guys had this lecture on last Friday about causation with Professor Adhikari, right? So she's amazing. Definitely try to take a class with her if you can after data 8. So, we talked about how association does not equal causation. So I just wanted to share a couple like kind of fun examples of where association is not necessarily causation. So these are some examples from this website. It's kind of funny. They have all kinds of really random things. So this is an example showing over time the number of worldwide non-commercial space launches, and then also the number of sociology doctorates awarded. And so you can see they move together like really closely. And this correlation, you'll see this number here, it says correlation 78%. So don't worry if you don't know what correlation is, you're going to understand what that is by the end of the course. But that's a decently high number is what I'll say. This number goes up to 100. So that's decently high. Just looking at this visually, like they seem to move together. So it's just kind of funny. Another example is per capita consumption of mozzarella cheese and civil engineering doctorates awarded. So some interesting relationship there too, it seems like. And then the last one is divorce rate in Maine, the state of Maine, and per capita consumption of margarine. So these actually move together really closely from 2000 to 2009. The correlation is 99.26. That's pretty high. So I don't know what that means. Somebody could study this, I'm sure. Cool. All right. So let's move on to actual columns and tables there. So we'll go into this in a second, but basically it turns out that columns of tables are also arrays. Actually, maybe we should just go into the demo to just make this a little bit easier. So let's do a little recap of arrays actually before we start. Also, a quick question, did Professor De Niro explain these 2 lines of code? He did? Okay, good, awesome, sweet. Okay, so we saw last time how you can make arrays with numbers in them. So for example, you could do like make array and just put whatever kind of random numbers you want in here, right? And so this would just make an array out of it. And you can do kind of interesting things, like you could do like multiply by 2, and it will actually like multiply everything by 2. you can also add two arrays together. So I could take like this array and add another array with like some different numbers. So I'm just gonna like change up these numbers here. And I could add them together. So you can do things like that. One thing to be careful here is if you're adding two kind of numerical arrays together, is make sure they're the same length. So if this one has 4 elements in it, and let's say this one I deleted one by accident, so I only have 3 elements. If you try to add that together, it's not going to work. So just be really careful about that. And it's kind of good to start reading these error messages when you run into them. You're not going to totally understand everything that's here, but hopefully there's some hints here. Basically, it's saying something like the shape of something is 4 and the shape of something else is 3. And there's some issue with that. So, it's okay if you don't totally understand the error, but hopefully you can look at it to try to get some hints. In this case, it's basically saying you can't add an array of 4 to an array of 3. Another thing that's kind of cool with arrays is you can also put strings in them. So, for example, I'm going to make an array of different kinds of tunas. So we'll put bluefin, albacore, probably the most famous tuna of all is Jim. And so we can take a look at our tunas here. And so Professor Junior probably mentioned this, but all your values in your array have to be the same type. So in this case, we're doing a string array. They have to all be strings. I can't mix and match and put like strings and numbers together. So another important thing to keep in mind. One unfortunate thing is some of the functionality that you're used to seeing with those individual data types, such as a string, don't necessarily carry over to arrays. So for example, if I did tunas times 4, that doesn't actually work. Even though we talked about how you can technically do that with strings individually, but with arrays, you can have issues sometimes. So not everything carries over. And then we also talked about how you can grab a specific element of this array using item. So if I do tunas.item 0, that grabs the first item in the array. So this is going to be really useful. We're going to actually use this a lot. It might seem a little bit trivial or silly, like why do we need to look at a specific item ever? But the main case we're going to do this is oftentimes we're going to have like a bunch of data in a really long array, and we'll want to like sort it in some way and grab like the first value in that sorted array. That's a really common thing that we're going to do because you want to maybe find the maximum value or something like that. And so that's a really common thing that we'll do there. And so just item is super important. Yeah, question? Yeah, why is the first term listed as 0 and not 1? So this is going to be a common thing in Python and almost all of computer science in general, is that we always start indexing things at 0. So 0 corresponds to the first thing, 1 corresponds to the second thing, and so on. So this is actually, it's going to be the case in pretty much every programming language. So yeah, something to get used to. I know it's a little bit of a, not totally intuitive, but just got to subtract 1 basically. And so, that actually brings up a good point, which is if you're looking at this array and you didn't know that, and let's say you wanted to get the last element, you might put 3 because there's 3 elements in here, but this is actually going to give you an error because it's going to say index 3 is out of bounds, basically meaning that 3 is like too big of a number for the possible values you could have put there. You should actually be using 2 to get the third element. So always kind of subtract 1 when you're using indices there. Cool. So now going back to tables, we're going to read in this data set, which we kind of played around with towards the end of last lecture. Basically has these salaries of all these different players in the NBA. It's a little bit out of date, but not too much out of date. And so this is all stored in a spreadsheet, a CSV file. So if you're not familiar with that, that's comma separated values. We'll actually go over that really quickly here. So this is what an actual CSV file looks like. So I can try to zoom in a bit so you can see this. So an actual CSV file will typically look like this. You'll typically have your kind of column names at the top and then the actual entries that go in each column below that. And you'll notice that each one is separated with a comma. So that's why it's called comma separated values. And the way to interpret this is like, this is the first row, which is technically just like the names of the columns. And then the second row is when the actual data starts, and so on. And so this is a common way to represent information. And we're just going to read that in using read table. So this is the function that we're going to use to do that. There's a couple things I'm doing here which you don't need to worry about too much. I'm just relabeling some of the columns to be capitalized basically. And then what we're going to do here is we're going to read in this table and then we're just going to pull in the warriors. So the way we do that is we take that table and then use the where method. So we'll do nba.where team, and then what does the team equal? Go ahead and say warriors. And so actually before we do that, maybe I'll just show you the actual table again, just so you can get a bit familiar. So here we have, looks like there's about almost 10,000 rows. And we have like the rank, the name, position, team, salary, and the season as well. So, you know, certain players might appear multiple times, I should say, if they played in multiple seasons. And so if we wanted to get just the Warriors, what we can do is NBA.where. And so what .where is going to do is it's going to essentially filter your table, and it's going to return a new table. So it's going to return a brand new table. It's not going to actually modify NBA itself. So it's going to look at the NBA table. It's going to say, let's find all the rows where team is equal to Golden State Warriors. Let's just take all those rows out and put that into a new table and then return that back. And so that's what we're going to do. And then we're going to assign it to Warriors. And so now if you look at Warriors, that has just the Warriors players. And so we can see all of those players here. And then if we want to look in the actual column itself, we can just do dot column. So we could do Warriors dot column. Let's say name maybe. And so we could get a name of the names of everybody who played for the Warriors since like 2000. Now, one difference between column and another method, which is called select. So select is also a common thing that we can do if you want to just select a particular column. Notice how if I run select, I'm getting the same information. So I'm seeing the same names here and actually the exact same order. So like just look at these first three names. Those are the same as the first three names here, right? But the difference is that when you use select, what it's actually doing is it's creating a table. It's just creating a one column table. So there's certain reasons why you might want to do that. But if you actually want to do some interesting math on your data, then you will typically do column instead, because column returns it in an array format. So that's the main difference between these two. So select returns a table, column returns an array. And so we're not going to do as much interesting stuff with actual names of players. It's kind of a lot of players. So let's just look at salary instead. And so these are actual numerical values. And so here we can see kind of different salaries of different players. And now we could go ahead and do some interesting math, like we could calculate like the average salary or something like that. So if we wanted to do that, we learned how we could do that last time. We can do np.average, and then np.average expects an array to go inside. And so this column method allowed us to get an array, and we can compute that average really easily. And then, you know, maybe you'd want to look at how the average salary of the Warriors compares to another team, such as like the Celtics, for example, just random team I picked. And so if we do Celtics NBA.where team, we could do Boston Celtics. So that's going to grab all the Celtics in there. And then we can run kind of the same thing for the Celtics. And then another simple way to compare them would even be to take like the difference. So I could just do this on one line. So I could do like, take the average of the Warriors salary, subtract the average of the Celtics salary. So we could do that too. And you can see what the difference is in the average then. So any questions about that? Yeah. Oh yeah, so NP is an abbreviation for NumPy. So if you go back up to the top here, there's these different modules that you can import. And so in this case, we're importing the NumPy module, which is a really common module for working with arrays. And you can actually name it whatever you want as a shorthand. So we kind of said we're going to import NumPy, but we're going to just call it NP. So we have to keep typing out numpy.average. It just gets kind of, you know, tiresome over time. Yeah. Yeah, so let's actually try that. What happens if we try np.average, but we use select instead of column, right? So if you run this, we get an error here. It basically says invalid array struct. So not sure exactly what that means, but basically it seems like it's looking for some sort of array and it's not getting an array. And that's basically what happened. So np.average, NumPy in general is built for arrays. And so it just doesn't work as nicely with columns, which is or I guess you should say a table really. Select is actually returning a table. So, you know, average doesn't really work on a table. It expects an array as the input. Yeah. Oh, for .item, can you do multiple individual items? I actually don't. That's a good question. I'm not sure. Yeah, I mean, my guess would be that it's only going to take one argument. Maybe you could do something like this. Maybe no. Yeah. Okay. So it looks like it's only taking one. So yeah, I guess you can't take you can't take multiple. There's going to be a different method that we'll use later, which lets us grab multiple if you need to. But item will pretty much always use it just to get one thing. And it's usually the first thing, usually, most of the time. Any other questions? Oh yeah, so we haven't totally covered that yet. You're talking about the R dot something predicate. Yeah, so I don't think we'll cover that in this lecture, but we'll cover it soon. But basically, for everybody else, like this where method is really powerful. This is the simplest way to use it, where we're just saying, show me all the rows where the team is equal to Boston Celtics. So if you just write Boston Celtics on its own, it's just going to say equals. But there's more complex things you could do. You could say like, show me all the rows where the salary is greater than something or less than something. So you can do more interesting things with it, which we'll get into next week. But for now, this is just saying like where the column equals this value. Yeah. All right. So yeah, just recapping here, a table of a column is actually an array of values. It kind of makes sense because we talked about how arrays have to have always one type of data in it. And when you're looking at a table in general, that's what you're going to see, right? Like if I see salary, I expect to just see numbers all the way down. I don't want to see like a random string in there. Something's wrong if I see that, right? So in general, when you see your data, your column should be kind of all the same data type all the way down. And then if you have a table, there's actually two ways to grab a column. So you can put the actual label, which basically means like the name of the column in quotes, or you can actually do table.column index. So you can do the actual index of the column. Like if I do 0, it's going to grab the first column. So you could do that too. We'll typically do this just because it's nice to explicitly write out what column am I getting. So that's pretty much how we'll do it. And then once you have your information in an array, typically you grab like a column out of your table, then you can use item to actually get the value at the index. And then there's a few ways that you can aggregate the values in the array. So, if you have your actual array, you can just pass it into the function that you want. So for example, I want to calculate the mean or the sum of all the values and so on. You could just do this. And NumPy has a lot of nice functions for us to do this really easily. And we'll use a lot of them. Another way, which is kind of cool, is you can also just do s.mean, s.sum, s.max. So we won't do this that often, but it is technically less code to do it that way. So you can do that. And the reason you can do this is because these arrays are specifically NumPy arrays. So these arrays are built using that NumPy module. So they have these functions attached to them, which is kind of cool. And so you can just take that array and just do dot sum, and it'll just sum it up for you. Yeah, question? What's the difference between column index and array index? Yeah, I guess we can see an example of this. So for example, I could have done warriors.column salary, or I could have done warriors.column and then just put an index. So actually, maybe just to show you guys, let's look at the table again. So this table has 1, 2, 3, 4, 5, 6 columns. So salary would be the 5th column, but I need to, change the index to 4. And so if I do where's a column 4, you can get the same information. So that's how we can use the index. So I'm just using kind of like the actual sort of index here corresponding to like 0, 1, 2, 3, 4. So that's the other way to do it. When you use item, it's going to get a specific item. So for example, I could say get the column at index 4 and then get the item at index 0. And that's going to get just this first element of that. That's a way of kind of using them together. Yeah. But as you can see, this isn't as clear. Like if someone's reading this code, they may not know what the fourth index corresponds to necessarily. So typically when you're doing things with columns, I kind of recommend just writing it out just so it's clear for somebody reading your code and for yourself if you're going back to your code later. Yeah. In the slide, it says aggregate. That really just means like a way to summarize your data with like 1 or 2 numbers. So there's 2 ways to like summarize your data. Like one way is you can call a function on the actual array. So for example, if I want to aggregate this using the average, then I could say np.mean, pass in the array, it'll calculate the average value. That's one way to aggregate. So aggregate basically is just saying like, simplify this information into like one number. So all of these functions let you do that. Like np.sum will actually return a single number. np.max returns a single number. So yeah, it's just showing you different ways you can do it. Like these two bullets are the two ways. Now there's a lot of different functions that you could have. These are just 4 examples of them. But the 2 main ways are like, one is call the function, pass in the array, or like just do the array dot the function. So those are 2 ways to do it. Any other questions? Okay, so one last thing before we actually start creating tables is ranges. So ranges are just a specific kind of array, and it's just a more efficient way to make an array. That's really all it is. Sorry, wrong notebook. So the reason ranges are handy is it just saves you time. So for example, if I wanted to create like a sequence of values from 0 to 6, one way I could do this is I could do make array 0, 1, 2, 3, 4, 5, 6, right? So that's one way I can do that. But it turns out another way you can do this really easily is you can just do np.arange, and then you can put in the number 7. And what that will do is it will just create a range of values from 0 up to, but not including 7. So if I just run this, I get the same exact thing. So I just saved myself a lot of time right there. And you can imagine this is really helpful if you need to make a range of values that are like in the hundreds or thousands, right? You don't want to go all day typing this out. So the arange lets you do that really easily. And it's pretty flexible. So you don't have to always start at 0. If you wanted, you could start at some other number. So I could go like 3 up to, but not including 7. You can do that as well. So do 3, 4, 5, 6. And then what's also interesting is not only that, but you don't have to necessarily always go up by 1. Like I could make something more arbitrary. So let's say I wanted to go from like 0 to 20 in increments of 2. I can do that as well. So you can pass in a third argument to specify how many numbers to go by as it increments. So if I do this, this will do 0, then jump up by 2 to 2, then jump up by 2 again, and so on. But wait, there's more. There's one more thing, which is you can also do it by fractional numbers too. So it doesn't have to be integers. So I could go like this if I really wanted to get crazy. And this is helpful sometimes. You'll do this sometimes in this course. So you can go up in increments of 0.1. So it's really powerful. And it turns out, it may not seem obvious right now, but it turns out that like making ranges like this is actually really helpful, especially in data science. You're maybe trying to generate random numbers or like go through like a lot of columns. It's really helpful to have the ability to make these kinds of ranges arbitrarily, right? So for example, like if I wanted to look at a certain set of rows of a table or something, like it'd be really easy to be like, oh, let's just make a range from the starting row to the ending row, and then just grab all the rows corresponding to those indices. You could do something like that more easily with this type of function. So this is something we'll use kind of throughout the semester. Any question about ranges? Yeah. Oh, can the range be decimal? That's interesting. We haven't really done that too much. I would imagine it would support that, but let's actually try it. Let's see or actually let's do a smaller number, like 2.1. Yeah, so it goes up to 2. So it looks like it is, yeah, it looks like it's working, because if I did 2, it's not going to go up to 2. Yeah, okay, cool. That's interesting. Yeah, I feel like I haven't really used it for that, but good to know that you can. Good question. Yeah. Sorry, can you say it again? Oh, why did display the numbers a little bit differently? I mean, I think it's just being explicit here that these are floats. So it's doing 0 points, just so you know it's a float. That's just typically how Python will do it. So you know that you're not talking about integers here. So for example, if we did this with like 20, then we don't get the points there. It's letting you know these are all integers as opposed to floats. So I think that's just how Python will represent it. And then that's how it displays it as well, just so it's like extra clear. There's some situations where that's important to know that you're dealing with floats versus integers, because you might have rounding errors if you're using one or the other. Yeah, that's a really good question. Yeah. Can you go backwards? Oh man, that is a good question. I do not know, but let's try it just for fun. Or sorry, not negative. What am I doing? Let's let's do this. Okay, I guess you can't go backwards. Does not support it. Looks like it just doesn't know what to do. Does not exist. Yeah, so I guess you can't go backwards. But you could, I think there's a reverse method potentially on arrays that lets you like flip it around. I'm not totally sure, but I think there could be a way to flip it. Yeah. Okay. Oh, wow. Okay. You guys are really trying to hack this, huh? Wow. That's impressive. Well done. That is really cool. Okay. I learned something new. Okay. All right. So I think we'll move on for ranges. That's pretty fun. Nice job, guys. All right. Cool. So creating tables, ranges are just a tool for kind of most of the rest of the stuff we'll be doing. So we'll go over a couple of the ways to create a table. One you've already seen, which is you just write out table.read_table, pass in a file name, typically spreadsheet, CSV. That'll just read it into Python. And then you can also just write table with parentheses without calling anything on it. And that will just create an empty table. And the reason you might do that is because you're kind of iterating and like adding information as you go. So you might start out with like a blank table and then you're like, okay, let's add these data points. Let's add some more data points into it. We'll do that as well today. And then technically all of these methods, which you've been using so far, all create new tables. So like the select method will actually select, a part of the table, like a certain columns. And then where will filter your table based on certain rows. And then sort will actually kind of sort the entire table based on a criteria. And again, return a new table. So all these methods are actually returning new tables effectively. And these are all different ways of creating tables, but kind of creating from scratch, really from nothing, it's going to be these two at the top most of the time. So let's go into a couple examples of doing that. So I'm going to try to just make a table from scratch. And what I'm going to do is it's going to have some very simple information. It's just going to have some streets on the south side of campus. And so we're just going to put the names of the streets here. So I'm going to do streets equals make array. We'll put Bancroft, Durant, Channing, and Haste. And then let's just take a look at this to confirm we have what we want. So I have these street names all in my array. They're all strings, so it looks good. And then I'm going to put these into a table. So first of all, let's just look at what table does if I don't do anything, just table with parentheses. So I get nothing essentially. It's just like an empty table. But if I wanted to add stuff to it, we can use a method or function called with column. So I do south side equals table. So it's just like empty table with column. And then what column do I want? Well, I want a column to be called streets. So I'm explicitly writing capital S streets in quotes here because that's what I want the name of the table to be, or sorry, the name of the column. And then what do I want the contents of the column to be? I want the contents to be everything that's inside this array. So I'm just going to put the name of that array here. And that's going to create it, add a column to this table. And so now if I take a look at what Southside has, it has a table, which is a single column table that's named streets, and it has the streets that we wanted. So we just created kind of our first table from scratch. And so let's say I wanted to then add a second column, which shows maybe the number of blocks that these streets are from campus. So Bancroft should be like 0 blocks from campus because it's basically on campus. Durant should be 1 block from campus and so on. So if I wanted to add another column, which contains kind of those numbers, 0 up to potentially 4, or sorry, up to 3, how could we do that? What's one way that we could get that information, at least in an array to start off? Not worrying about adding it to the table yet. Yeah, so we'll do the with column, but how do I get the actual, so actually, okay, we can go ahead and start that out at least. So we'll do Southside dot with column. Let's just call this blocks from campus. So kind of a longer column name, but that's okay. And then what should go here as the second argument? So I want this to contain the number of blocks from campus starting from 0 for Bancroft. Any guesses on how I could get those numbers into an array? Yeah, so we can use range. So we can do np, nice job. We can do np.arange 4, and that will give us the numbers 0 up to 4. So 0, 1, 2, 3. And this is basically what we wanted. So we wanted essentially another column that just represented for each of these streets, how many blocks away is it from campus, right? So now we've done that. And so now if we take a look at Southside, we notice that it only has one column. So any guesses why we just did all this work and how come Southside only has one column still? Yeah. Yeah, we didn't set it equal to Southside. So when you do, it's gonna get a little tricky, but just remember this, like when you're doing these kinds of methods and operations on tables, they're just returning new tables. They're not actually modifying the table. So you have to always remember to assign it back. So if I actually want to update Southside, I need to do Southside equals Southside with column and whatever I want to add to it, right? So a little tricky. You'll definitely run into this, but over time you'll start to get it. Cool. So now we have our table and we have our both of our columns. And so now if I run this and then run Southside, now it actually has the column in it, which is great. One other way that we can actually make this table really quickly, instead of having to do with table over like two different blocks of code, we could actually do this all in one block of code using with columns. And the way this works is I'm going to write this out over a few lines. It's actually all just one expression technically, but I'm just writing it over a few lines so you can see it. So I can put everything we've been doing above into one thing. So I can say first column is going to be called streets. It's going to contain the data that's contained inside the streets array. Second column is going to be called blocks from campus. And that's going to contain the data inside np.arange4. And so you could run it like this, and then it creates that table as well. So it just does it all in like one expression. You can this is also fine. And the reason I do this is because technically you would write it like this, but it just gets a little bit hard to read when you do it like this. It's just one line of code, but you're allowed, when you're doing parentheses, you're allowed to like split things up just to make it a little bit easier to read. So we'll do that pretty often here too. Cool. So any questions about making tables? Yeah. Could you use predicates like r.above? I don't think you can use those for constructing tables. Those are just for where. It's like specific to the where function. Yeah. Any other questions? All right. Okay, so just recap of ranges as well. It's an array of consecutive numbers, so that's really important. And typically we'll just use np.arange with the end number in there. Really important to remember that it's from 0 up to, but not including that number. And then we also have arange where you can put a start and an end. Same thing, it starts at the start number, but does not include the end number. And then lastly, we can add a step if you want to actually split it out into like arbitrary steps that we care about. Cool. So let's look at an actual example of an actual interesting data set from 1900. So this is a kind of historical example. So this is Du Bois. He was a scholar, historian, activist, basically one of the first data scientists ever. It's really cool. And he was founder of the NAACP. And what we're going to be looking at specifically is some of the work that he did for the 1900 Paris Expo. So this is 1900, go back to that time, obviously like segregation is the norm. And there weren't even really any like photographs of Black people. And so he wanted to just educate people about the lives of Black Americans. That was really his goal. And so he took like hundreds of photographs, made a bunch of patents, really tried to share kind of the Black experience. It was really cool. And this was like just groundbreaking because so many people had no idea, how these other people live. I mean, it's crazy. So, and in addition to that, he also made 30 handmade statistical graphics, which doesn't sound that impressive because it took 3 months. But again, he didn't have Python to do this. There's no computers at the time. So he's literally like making them by hand. And there's no he's not even using a printing press for any of this. So it's pretty crazy what he accomplished. And we'll look at one of those graphics today. And a lot of those are in the Library of Congress. So here is one of the ones that he made. So again, all made by hand. So like literally all this is made by hand, which is just crazy. So take a look at this for a couple minutes and try to see if you can get a sense for what is being shown here. So just take a couple of minutes to look at this and discuss with the person next to you if you feel. All right, so let's try to discuss this. Oh, I guess one thing I forgot to mention is that this data was collected from, I think it's about 150 families that he surveyed. So that's how that's kind of how this data was generated. So I guess anybody want to explain what we're seeing here? Any interesting things that you're seeing? Things that stand out? Yeah. Yeah, so we're seeing kind of expenditure based on class. And so the way he categorized class was he basically made income brackets. So we have these different income brackets here. So you have like 100, 200, 200, 300, and so on. And then he also has kind of the actual average household income within each of those brackets, right? And then the kind of colorful stuff is how are they actually spending that income? What's the kind of distribution of all these different categories that they're spending it on. And the categories are up at the top here. So you have like rent, food, clothes, direct taxes, and then just kind of other expenses and savings. So those are kind of put together to simplify things here. So any interesting, I guess, things that you notice just based on looking at the graph? Yeah, so it's looking like the highest class right here, which is kind of 1,000 over, the percentage of the income that's going to taxes is only 4.5%, which is actually kind of low if you look at some of these other categories here, right? I mean, obviously at the very bottom, you don't have as much, but as you go up, there's actually some people here who are paying a higher percentage, which is kind of interesting. Anything else? Yeah. Yeah, exactly. So that's a big one, right? So as you get into the 750 category, the rent disappears completely. So they're probably buying homes at that point. They're not renting. Yeah. Anything else that stands out interesting? Yeah. Sorry, can you say that a little louder? Ah, yeah, got it. So the people kind of in the lowest bracket are paying a lot for clothes compared to other people. That's actually really interesting, right? This 28%, that's the biggest percentage here. Yeah. Yeah, that's right. It's this larger percentage of small numbers. So that's actually a really good point here, is that when you're comparing these percentages, you have to also keep in mind that these are percent of a value. And so the overall value for this first row is going to be a lot less. So the actual kind of like raw dollar amount might be a lot less. But it's still interesting that like as a percentage of what you have, that's what you're paying more, right? So, but yeah, it's good to keep that in mind. And we'll explore that in a second too, which is the difference between actual percentages versus the actual values. Cool. So we actually have this information in a spreadsheet. It was actually the spreadsheet I showed you earlier, that CSV file. So we're going to just read that in here. So we're just going to do Du Bois table.read table, and then we just pass in the name of the spreadsheet. So it's Du Bois.csv, and we can take a look at it. And so here we're seeing basically the same information that we just saw on that graphic. And so we have the same columns. So we have kind of the class, which is kind of his income bracket categories that he came up with, the actual average income within each category, what percentage are they spending on rent, what percentage they're spending on food, and so on. And then lastly, he also put kind of like what he deemed as like a status. So he kind of said these two are considered kind of poor, these are considered fair, comfortable, and well-to-do. So we have kind of a breakup there. So kind of a question for you guys, how could we figure out which class spent the highest percentage on rent? So again, we just want percentage of rent, and we want the class that corresponds to the highest percentage. Yeah. We could use the max function. We've only used it for like a smaller set of values though, but that's potentially one way you could do it. But if we're trying to just use, I guess, table methods, how could we do this using table methods? Maybe this question behind, yeah. Yeah, so we could sort. So that's definitely a good kind of first step, right? So let's take our table, and then we could do sort. So we would sort by rent, right? So let's just see what happens if we do this, first of all. So if we sort by rent, we have things kind of increasing. We actually want to figure out the category that has the maximum value. So what we'll want to do maybe in this case is sort with descending equals true. and that'll actually flip the table. So now it's the maximum value is basically at the top now. And so we've sorted the table, we have it. And I mean, we can, now it's obvious you can look at the table and figure out what the class is, right? But if I want to actually return the value with Python, I go another step further. So once I've sorted this table, then what we can do is we can grab the actual column corresponding to class. So because we want to, ultimately we want to get this value out of this table. So if I want to get this value, kind of the first step is, let's just get this entire column. So we can do this. So now we get the entire column. And then all we say is we want the first value in that column. So we could do item 0. And so that gets us the value kind of in the, that corresponds to the highest percentage spent on rent. So just to recap again, I'll maybe just show this in steps too, so you can just see the output each step of the way. So first thing we did was sort the entire table by rent, specifically descending equals true, because you wanted the maximum value to come up at the top. Maximum value comes first, and then it goes downwards. Once we did that, then we said, let's just grab the class column and then just grab the first value. So dot item 0. And so this sort of technique is going to be really common. This is how we're going to typically use this item, and item 0 specifically. We'll like sort our table by some criteria, look at some other column, and then grab the first value in that other column. That's a really common pattern that we're going to see. Cool. So maybe one last thing we'll do is there's some discussion about like, well, these are percentages, you know, not exactly comparable sometimes. Let's look at absolute values, actual values of dollars spent. So let's specifically do this for food. So let's take a look at how much is actually being spent on food in terms of dollars rather than percentages in each class. And so one way we can do this is we can take the actual average income column, which is the actual amount of money they're making on average in each kind of class, and just multiply that by the actual percentage spent on food. So they could do something like this. And the reason I can do this is because when I do column, that makes an array. And so I have 2 arrays here, and you're allowed to multiply 2 arrays together. It's going to just multiply each element together. So it's going to do like 335.66 times 0.43 and so on. So if we actually do this, we'll see, thank you. I need to do underscore Du Bois. So this is actually a good example of an error that's actually common. So it's saying the name Du Bois is not defined. And so if I just copy this here, I typed it wrong. And so now it actually works this time. And so now we actually we can look at the actual amount spent in terms of dollars, not percentages, by each class. So this is another common thing that we'll do is when you have your data set, you're going to have you can have information in different formats and like different pieces, and you're going to want to combine them together. So we'll often create new columns out of existing columns. And so looking at it like this, I can kind of look up and down, right? Like you can go up and say, okay, this first one's 300 to 400, this next one's 200, 300, and so on. But it'd be really nice if this was just in the table and I could just see them together. And we learned today how we can do that. We can use with table. So we can do Du Bois with column, not with table, with column. And then we could call this like food dollars, for example. And then we could just pass in this thing that we had up here. So I'm just going to copy this and paste it. And so now we can look at it together. And so I can see the actual amount spent on food compared to the percentage. So for example, like if you're looking at percentage of food, right, the 1,000 over is the smallest percentage. It's 29%, but that doesn't mean it's the smallest amount actually spent on food, because if you look at the raw dollar amounts, it's actually the maximum spent on food. And so again, it's going back to the fact that this is a percentage. We have to take into account what this is a percentage of to look at the actual value. Yeah. Oh, is it possible to insert the column within food and clothing? So we can rename and like reshuffle columns afterwards, but by default, it's going to add it to the back. Yeah. Cool. All right, we'll stop there. Yep. Have a good weekend, guys.
Today's the last day to swap sections.
Oh, also apparently today's the last day to swap sections. So if you're trying to do that, please do that today.